Okay, so we're officially recording and I'm sharing. And today's lesson is going to be lesson 14. And I would like you to start by downloading the contents of Nut and Bolt. And the other thing I would like you to do is there is an inch assembly template.asm dot. Okay, I want you to download that, put that in your templates folder. And so for me, what that looks like, I'll go over to downloads. I'm going to cut it out of my downloads folder. I'll go over to documents. There. And I put it in my Solidworks Templates folder. And if all goes well, when you come back to SolidWorks and you click on your SolidWorks templates, you should see the inch assembly template. I hear a lot of crickets chirping. Is everybody good with that, or are you still like pre-coffee? I see Emmanuel nodding his head, so he's good.
I'm good.
Okay, Sam, you're good.
I'm good.
Alej, you good? Or are you doing the two-computer thing?
Yeah, I'm good.
Okay. All right. So today we're going to take a bunch of piece part models and we're going to put them together into assemblies. These are going to be associative assemblies. So I can go in and I can actually change the solid models and have the assembly update. So let's actually create one while we're here. So I'm going to click on that inch assembly template. And it should come up just like this. And it says, okay, what's the first part that you want me to drop in? Now, I want you guys to be kind of judicious about the first part that you drop in. Okay, generally in most of the machinery that I've ever designed, there's going to be some kind of a major frame, there's going to be an engine block, there's going to be something that you're going to assemble a whole bunch of parts onto generally. I would encourage you to bring that in first. Okay, so in this case, we don't really have anything super specific, but I'm going to click on part 004 and I'm going to say open. And it brings in a bolt. So we're going to do probably the world's simplest assembly of just putting together a nut and a bolt. Now, here is something critical that I want you guys to take note of. Over in the Assembly Manager, you'll see a little F next to 0004. Okay, that means that the part is fixed in space. So if I grab it and I try to drag it around, it doesn't move. Every year, a whole bunch of seniors come to me and they say, Mr. A, I've got a drawing, an assembly drawing, and I'm trying to dimension it, and all it's giving me is angles. And I say, did you bring the first part in skewed? Did you float it and fix it onto the the principal axis? And they say, no. I say, okay, go back, float the first part, mate it to the principal axes and planes. That'll square everything up and your layout will work perfectly. They run off, okay, and they do it and everything's good. So once you drop the first part in, what I want you to do is right click, click on float. Okay. Now you can grab the part, you can move it all around the screen. Now we're going to apply geometric mates to get this thing fully constrained in space. So for example, I can click on mate, and I'll click on the cylindrical shaft of the bolt. And I have all the usual kinds of options that you would expect from the good old sketching relations. Coincident, put something right on top of each other. This one's good for when you want to put two faces right up against each other. Parallel, perpendicular, tangent, concentric, lock. I don't ever want you to use this one. That will thoroughly mess things up. The distance criteria, angle criteria. Okay, so nothing that you haven't seen before in sketching. And it works in a very similar way. Okay, so I've chosen the cylindrical face. And I'm going to choose axis 1. And SolidWorks grabs the most reasonable assumption for an axis and a cylindrical face. And it says, oh, you must want that concentric. If so, just hit the little green check. Okay, so now I'm constrained. I can rotate about the axis and I can slide along the axis. Next thing I'm going to do, I'm going to click the top plane and I'll choose the bottom face of the bolt head. This time, it's saying, oh, you must want it concentric, or excuse me, coincident. Okay, I mean, that might be okay. Or I might want it at a distance. So maybe I want it 1 inch up from that plane. So I'll just put in 1 inch. I'll say okay. And now I've got the bottom of the bolt head 1 inch from the top plane. However, I still see an underdefined down here. So what's going on? Well, let me grab something. Just like sketches, if I don't know what's going on, I grab a line and I try to drag it. Okay, I see that the only thing I've got going on now is rotation. So what I can do, I'll click on this face, and maybe the front plane, and I can either make it parallel or I could set an angle. Either way is fine. Let's do parallel. We haven't used that one before. And now I have a fully defined bolt. I use the green check. And this thing is locked in space. So I have the origin and the orientation set. Okay, not too bad. Now let's add another component. But first, let's get rid of these planes and axes. So we'll do View, Hide and Show. Let's see, axes are turned off, and let's get rid of the planes. Once I bring in the major, like frame or block or whatever the case may be, I generally turn off the planes because it just gets too busy. All right, so we got part 0004. And now let's do Insert, Component, and we're going to do Existing Part or Assembly. And I'm going to choose 0005. and I'm going to bring in a nut. So now try to just think about it logically. First thing you probably want to do is make the center hole of the nut concentric with the shaft of the bolt. Okay, and we're going to do that with mating. So we're going to mate the center hole to the shaft of the bolt. Okay, so that's good. And maybe I'll do this face. Well, that didn't work very well. Let's take a look why. So Solidworks is saying, the operator probably wants coincident. But in this case, I'm up above all of the threads. So if I try to tighten it that far, I'm going to strip out the threads and probably break the bolt. So that's a bad idea. Let's do an added distance and get our nut back down onto the threads. So maybe 2 1/4 inches might make sense in this case. I'll say okay. And again, I'm left with nothing but rotation for my nut. So as always, I want to fully constrain this. I've got 2 faces. SolidWorks says, you probably want coincident. Let's try an angle this time. So this time we'll set the angle at something really boring, like maybe 180 degrees. Okay, and I have a fully defined assembly. Now whenever I go in and I want to make a change to a component, it automatically gets reflected at the assembly level. So let's demonstrate that. So let's say I want to use this like an aircraft style bolt. So with aircraft bolts, what you do is you drill a hole across the head and you can put safety wire so they don't unscrew. So let's do that. I'm going to go in. I'm going to open the part and it's going to gripe at me. I'm going to put a hole right through that face. Let's choose something appropriate. Yeah, that's not bad. We typically only use like 25 thousandths or 30 thousandths safety wire. Uh-oh. Only 2 decimal places? That's no good. Okay, so now I have a hole in my bolt. So I can put my safety wire through. And when I close it, I can see this back at the assembly level. Okay, so everything is associative. In some early CAD systems, what you would do is you would import the solid geometry. Okay, in SolidWorks, we're a little more advanced. An assembly file is nothing more than a whole bunch of links back to the components. Okay, so there's no solid geometry in the assembly file. It all just links back to the component files. So when I update the component files, I immediately reflect the update in the assembly. Okay, let's also double check Okay, so if you got the assemb dot, you should have all of your attributes filled out, because these are going to be necessary when we do assembly drawings. When we tell people, what part number do you want to bring in? Where do I place it? How do I tighten it? Do I want to put glue somewhere? We're going to put all that information in the assembly drawings. Okay. So let's see. And then over here, well, let me just say this, guys. On your own, before you go any further, go into your empty assembly template and change it to 3 decimal places so that I don't make the graders upset. So be sure to save this. Because I believe I have you handing it in for homework. Okay, and just like drafting, because the assembly is nothing more than links, be absolutely sure that when you submit your homework, you send the assembly file and your components. Okay, this is where it becomes important to use the zip file. So don't just do a whole bunch of attachments. We're going to do a V8 engine, and that one's going to be a significant amount of components. Okay, let's do another example. Brake drum with studs. Okay, go ahead and download these 2 components. And this would actually be a good time to actually fix that template. So we'll get rid of this begin assembly business. Okay, so you go under document properties, detailing. It actually is 3 decimal places. Primary, secondary. So why did it come up 2 decimal places?
I think that was just in the part drawing because it said it was an older file.
So the components were older, yes, absolutely. But that shouldn't have been a problem for the assembly. The assembly should have been just created in this version. That should have taken care of it. Hmm. 3 decimal places there. Okay, I may have to get to the bottom of that. So once we get past the exam, then I will have a resolution for that for you guys. Okay, so we've got a new assembly here. Let's bring in some components. Insert component, we'll do existing. And let's bring in the brake drum. It should look somewhat familiar. And we'll bring in another part, we'll bring in the wheel stud. Okay, so just like the last time, this big brake drum, this is going to be the basic fundamental part that everything's going to get installed on. So let's start off, we're going to float that first part. Note, the second part was not locked in space. I don't have to float the second part. It's only the first part. So even SolidWorks is kind of assuming, oh, you're going to bring in the basic part, the block, the frame, the whatever to assemble stuff on. Okay, so this brake drum, let's see. I think I want to put my bore concentric with axis 2. So we're going to mate it. I'll choose the interface. I already had axis 2 selected. And it's saying concentric, so I like that. That's good. Okay, I do this problem specifically because it gets a little bit weird where the part is cylindrical. Okay, so I can still move in this direction. So let's fix that. And I think I will put, let's see, maybe the back edge, that little face right there. I'll put that on the right plane. That coincident will work fine. That's nice. Okay, I'm still underdefined. Why could that be? Well, I still have a problem with rotation. So it would be really nice if I had one of the bolt holes aligned to the principal planes in the original part. Okay, it's going to make drafting and detailing much, much easier rather than having some screwy angle. And this is where it gets a little bit strange. So I'm going to choose the front plane, and I'm going to want it to run right down the center of this hole. Okay, so right now it's choosing tangent. Okay, that's reasonable, but it's not what I want. Instead, for this one, you got to use distance, which I've always thought was a little strange. Make sure that you have the center to center option clicked. And if you've got a distance of 0, then I should be looking right down the bore and everything should line up, which it does. So I'm aligning this plane right on the center of the hole. In some other CAD packages, you could use tangent, and tangent would have put this plane on the center of the hole. Not so in SolidWorks. You got to use distance.
Can you go over that last mate, that last mate real quick?
Yep, absolutely. Okay, so we have why is this not rotating? Okay, so my brake drum still has a degree of freedom for rotation. And what I want to do is put the front plane right here, this front plane from my assembly, and I want it to go right through the center of this hole. We're going to do that using a distance mate. So I'll choose front as a pre-select, and I'm going to choose this cylindrical face right here. SolidWorks is assuming that I want tangent. That is not the case. If I want this plane to go right through the center of the hole, I'm going to choose distance. I'll set a distance of 0, and I'll say center to center right here. And now, once I apply the distance mate, now I've got this plane going right through the center of the hole. And I'm good. However, my wheel stud can still move all around. But I've got the basic unit, I've got the frame, I've got the big thing that I'm going to add parts to fully defined. So let's turn off some of these planes, make things a little less busy. Some of you folks may have never seen a brake drum before. I saw that in last year's class, which I thought was rather interesting. The way we install this is a piece of threaded rod with a shoulder, and we push it in from the back, and the threaded end should be hanging out on this side. So we're going to mate it. I'm going to click on that face. And in the real world, we come up with a big pressing tool, and we press those two faces together. Okay, so that's going to give us the correct distance going into the part. But now we also need to put it in the hole. And that's where a concentric is a perfect mate. So now I have the shoulder up against the back face of the drum, and the threaded rods are sticking out. So I could do that 5 more times, which would be completely legit. But there's an easier way to do patterns of parts. So just as in sketching, we saw patterns for curves and lines, and then for features, we saw patterns. For components, we also have patterns. So if I come over here under linear component pattern, there's also a circular component pattern option. As always, I'm just going to march right down through the dialog. First one is my center of rotation. So I can choose any cylindrical face or edge. Oh, let me choose that edge. The number of occurrences I want. So I want 5 total. And I'm going to choose the component to pattern, which in this case will be my wheel stud. And I'll say OK. Now you'll notice there's a minus sign on the wheel stud. So this is not a fully constrained assembly. I'm not going to get really crazy over some things. You know, on this wheel stud, there is no feature that I can align to dimension the clocking of this wheel stud. Okay, if I give you something like that, don't worry about the underdefined. You know, I think if I was paying you guys $100 an hour at some company, if I was to be worried about every time you didn't have a bolt head fully constrained, you know, I'd be paying for nothing. So things like bolt rotations, I don't worry about those guys. Okay. So that's another good example of how to do an assembly with a component pattern. Again, save this one. Okay. Do one more. And then I want you guys to go in and do all of these and submit them for homework. Back under lesson 14. Let's assemble my trailer hitch. So let's download these. And let's bring in the trailer ball first. Okay, so this is going to be that big central object. So the first thing we're going to do is float it, as always. So now I can move it all around. Let's mate this thing so that it's fixed in space. Blah. That wasn't fun. Coincidence is good for that one. Sometimes there are situations where you can't pick directly on an object. You need to pick through an object to reach another face. That's a good time to do the select other command. This allows you to pick through. So I clicked right here, but I want the bottom face. So I'm going to do a select other, and the first item of the list is going to be the next face down. So that gave me the bottom face. And I'll choose the top plane. And coincidence is fine. So now the only thing I need to constrain is this direction. And I'm good. So I'm fully defined. That's nice. Okay, let's bring in some more parts. I'll bring in the pin. And the trailer clip. Okay, so this pin keeps this part from pulling out of the back of the car. This pin goes right in this hole. So I'm going to mate the cylindrical face to the hole. And I can drag it in and get it roughly in the position that I want. I'll set the distance in. So let's see. Oh, maybe 0.875. Okay, and I can still rotate this thing. Drag my clip over. I'll put the clip in the hole. So now this thing can rotate. I'm not thrilled with that. Okay, here's a trick that you guys are going to need to use in your Stirling engines. Sometimes when you have weird geometry like this, especially when it's a swept figure, those can be really, really hard to mate. So what I've done is I've put a little flat spot right here on the part. That makes constraining it much, much easier. So for example, if I want to make sure that the pin is always up and down, I can click on this flat face right here and the top surface, and I can say, make them parallel. Now the only thing the part can do is move like this. Okay, the next logical thing would be I want this hump right here to be concentric with the pin. And I might have a problem doing this, but let's try it anyway. So I'm trying to find the little flat spot right in there. This might be another good time to do a select other if I can hit it. So I'll choose that face, and I really got lucky on that one. And I'll choose the outer face. I'll say concentric. Okay, that's what I thought. So there's no way for the center of this arc to be centered on the pin. But let's go ahead and do it anyway. Let's take a look at how you fix an error in mates. So we'll intentionally do it wrong. So we'll choose that and this. And we'll say concentric. And we'll say do it. Okay, so when you make a mistake, the way SolidWorks tells you you have an oops is by making the components in red, and all of the mates that you have for your assembly are right here under your mates folder. Okay. So you have a hard error in this concentric, which is affecting the ability for all these others to be properly solved. If you want to get rid of the mate, I'm going to right click and say delete. Okay, now there's a valid solution for all the other mating criteria. If you want to see the mates that apply to just a certain component, you can come up under the component and you can go into the mates folder. So these are all the mates in this assembly that apply to the trailer ball part. Same thing for the pin. So if I come under the mates, here are the current 3 mates that apply to the pin. And sometimes that can be pretty useful. Okay, so because I drew this wrong and I can't do a concentric on this bump right to the pin, There's a couple things we could do. We might be able to do a tangent right here. I think that would probably work. So let's do a tangent. We'll do a select other. Okay, this time I wasn't over the face. Okay, so now I've got the little face inside. I'll choose mate, the cylindrical face, tangent. And now this face, that little sliver face in there, should be just touching the pin. If I try to move it, I can't, so that's good. And I have a fully defined assembly. Okay. So that is how you do assemblies in SolidWorks, at least really basic ones. We're going to do some fancier stuff after the exam. Okay, so let's go back. And let me make sure that I didn't miss anything in the... So I gave you guys the template. We did the trailer ball. We did the brake drum. If you're just dying to hear that spiel again, there it is. All right, so I didn't leave out anything. That's good. Okay, so what I want you to do, guys, I want you to go through, do exactly what I just did and practice. So your homework due for next Monday will be the brake drum with studs. So practice doing a component pattern, assemble the nut and bolt just like I did, and do the trailer hitch by putting the pin and clip together inside the main casting. Okay, so we have 6 minutes left. Does anybody want to go over anything on the exam? The rest of the time is yours. Otherwise, you're welcome to begin the homework and ask questions if you have issues.
Professor,
Yes.
will- in the exam tomorrow, will we be like doing drawings or like?
No. So tomorrow is going to be just modeling. You'll be given 3 blueprints. You've got to give me back 3 solid models. It's going to be just like the last exam, just with different components.
Okay.
So closed everything. Yeah, I made up 3 new prints, and this time sheet metal is fair game. So I can ask you sheet metal problems because you've done the homework on that, and your sheet metal homework should be back at this point.
Okay.
What should we do for lesson 13?
Okay, so for lesson 13, what I'm going to do is make a video, and you guys will be on your own to just watch it. So
Do we need to submit anything?
that's a good question. Probably, yeah, I'll give you something. In typical years when I did that in class, almost everybody got it done in class, handed it in, and walked out the door. But don't underestimate it, okay? Hand drawing of isometric is really, really useful. I've used it a lot. So, you know, by all means, do it and become proficient with it. Anything else, folks? Okay. Then,
I had a quick one.
yeah, Sam.
In the the graders for my like drawing homework, she said she couldn't access the parts, like they weren't linked to the drawing or something. Do you know
Okay.
anything about, like, how would I save it so they are linked?
Okay, so it sounds like you fell into the classic trap. Did you save your parts and then like rename them after the drawing was closed to clean things up or something like that?
You mean like save the individual parts that I downloaded from the lesson?
Yeah, what I see a lot year to year is people will do the drawing, everything's great, looks fine. They'll close the drawing and the models, and then they'll say, oh, I don't like the name of this, I want to change it. Maybe put your name on it, put your initials on it, and that screws up the link between the drawing and the model. Okay.
Okay, so
If you did
renaming the,
Yeah, renaming it with the drawing closed is a huge no-no. And that's what they're probably griping about.
okay, so when can you rename it? Just when you have the drawing open?
Exactly. In
Okay.
that case, you want to do something like a save as, and then you can rename it whatever you want, and the links will all remain established.
Okay.
I have a question on the homework for the trailer hitch. How did you lock that pin so it didn't rotate or like move back and forth in the actual tube?
So the way I did that, I set a distance from this face to this face. So you can see it right here under this distance mate. Okay, and then to constrain the rotation, I made that little sliver face right here parallel to the top of the tube. So that's set distance and rotation.
All right, I see. Perfect. Thank you.
Yeah. I mean, if you guys do something slightly different, I don't really care. As long as you get to a fully defined assembly, that's all that really matters to me.
So,
I have a question.
Yeah, Aaron.
okay. Someone else said I have a question, so they can go first, but I also have a question.
Okay. Someone
Yeah.
else, you're up.
That would be me. When I put the trailer hitch in, it's not like letting me like mate it to the like
Principal
faces.
planes.
Yeah, the planes.
Okay, float it first, then you'll be able to mate it.
Okay, how do I do that?
So what you're going to do, let me see if I can. So if I bring in, so when you bring in the first component, it's locked in space. You can't drag it around.
Mm,
What you want to do is come over here, right click on that first component and say float.
oh, okay.
Now you should be able to grab the thing and move it anywhere you want.
Yep.
Then mate the component to your principal planes in the assembly. That'll make sure that that first component is nice and square and doesn't give you any problems when you go to create the drawing. Okay, so back to the other person who
Okay.
graciously gave up the screen.
Yeah, so I was just wondering, is it illegal to mate planes to planes?
Not really. I mean, I find it a little bit awkward. I find it nicer to mate things the way you would actually do it in real life, which is generally, you know, faces to faces. I try to simulate the actual mechanical assembly as close as I can in the CAD world. So technically, no. And there are some times where you just may have to do it. So if you've got some, ergonomic coffee maker and there are just no uniform faces on it, yeah, you might have to mate it planes to planes.
Okay,
But I would say try to do it the simplest possible way and match the mechanical assembly first. Then if you got to get exotic, then get exotic.
okay, thanks.
Because you always got to think about, who's going to pick up your work after you're done with this? In 6 months, is the guy in the cubicle next to you going to take over? And you want it just as simple as possible so that if the worst CAD operator in the company picks up your stuff, they can look at it and go, oh, okay, I see what's going on. Okay, so we're at 8:54. I'll hang on for another 5 minutes and then I'll end the meeting in case anybody else has questions. And if you guys need to book out to your next class, feel free to take off.
Thanks.
So, to create a zip file,
Yep.
do you just, select all the things you want in it and then right click and hit send to compress zip folder?
That's all you do.
Okay. Because mine's like a WinRAR zip type or whatever. I don't know if that's okay.
RAR is something that Apple likes. So what I would rather see you guys do, so like on the trailer problem, if I select those 3 files, I right click and I say send to compress zip folder. Now I have a trailer pin.zip. This I can rename, that's totally fine. And that will have the 3 components in it.
Okay.
And make sure your assembly is in there with the component files.